Welcome to Best Academic TV. In this video, I'll be taking us on the application of Newton's second law. In this series, I'll be taking us on the application of Newton's second law. All right, we are given a question here that is a 3.0 kg. 3.0 is the same thing as 3. Please take note. A 3.0 kg of mass. The first parameter given to us here is the mass. The mass is 3.0 kg, which is the same thing as 3 kg. Undergoes an acceleration. So the acceleration here is 2.0 I, and I, that's in vector. This is the acceleration plus 5.0 j in vector. The unit is meter per second square. That is the unit of acceleration. Class, we are asked to calculate the magnitude. This statement here is very important. The magnitude of the resultant force. Okay. But this is what you should understand here in physics. That whenever mass is given, the mass is given, the acceleration is given, and we are asked to find mass. At that point, we apply Newton's second law. But before we solve this first, let's write down solution. All right. Class, we are given mass. That is, the given parameters are mass, and the mass is 3.0 kg, which is the same as 3. The acceleration is equal to 2.0 I plus 5.0 j, all in meter per second square. And we are asked to find the magnitude of the resultant force. Okay. Now, this is what you should understand here. Whenever mass is given to us here, acceleration is given to us, all right, and we are asked to find force. There is a formula that connects mass, acceleration, and force together. Please listen to me carefully. There is a formula that connects mass, acceleration, and force together. And that formula is taken from the Newton's second law. That is F. Please take note. F is equal to mass times acceleration, which is ma. Please take note of this, okay? So this is a formula that connects mass, acceleration, and force. But if you look into it here, the mass is given and the acceleration is given, and we are asked to find the magnitude of the resultant force. Later, we are going to know what magnitude is, and we are going to know what resultant is, okay? But let's just replace the given parameters first before we can understand what magnitude of a resultant vector is, okay? So now let's replace the mass, the value of the mass, and replace the value of the acceleration, okay? When you do that, F will be equal to 3 into 2I plus 5j. Please take note. So there's something you should understand here in mathematics. whenever there is involvement of brackets in any mathematical expression, the first thing to do to move to the next level or to move to the next step is to open the bracket. Please take note. So now let's open the bracket here. This guy will times this. When you do that, we have this to be 6i plus this. We multiply this. We have this to be 15j. So this is our force, but this is not the magnitude of the force. This is our force. This is our force, yes, but this is not the magnitude of the force. And we are asked to find the magnitude of this force. Class, there's something you have to know here. Know that finding to calculate the magnitude, either I call it magnitude, or you call it absolute value, or you call it modulus. Please listen to me carefully. It can either be called magnitude or absolute value or modulus. So these two words here are the same as magnitude. Please take note. So for us to find the magnitude of vectors in three dimensions, this is vector here because the value of the I here is given to us here. The value of the j here is given to us here. So whenever you have ijk, we qualify that to be a vector. Whenever you have ijk, I'm going to explain that later, okay? So how do we find the magnitude of vectors in three dimensions? So whenever I want to find the magnitude of vectors in three dimensions, you apply Pythagoras theorem. Whenever I want to find the magnitude of vectors in three dimensions, you apply Pythagoras theorem. Please take note, okay? Now let's try to represent the formula for magnitude of vectors in three dimensions, okay? But before then, this is what you have to know here, that this I you are seeing here as a vector can also be written as S as a letter, okay? Now this J you are seeing here as a vector can also be written as Y as a letter. And this K you are seeing here as a vector can also be written as Z as a letter. So when you see I as a vector, is the same thing as S as a letter. When you see J as a vector, is the same as Y as a letter. When you see K as a vector, is the same as Z as a letter. So remember, I told us that whenever you are asked to find the magnitude or absolute value or modulus of vectors in three dimensions, we apply Pythagoras theorem. Please take note. So now if I have something like this, class, this is a sketch of this. I have something like this. Sorry for this. I have a sketch like this. This is my Y, this is my S here, and this is my A. For me to represent the magnitude of A, which is this here in the hypotenuse sides, okay, I will apply Pythagoras theorem. That is, the square on the hypotenuse is equal to the sum of the two squares in the right angle triangle. Please take note, that is this here. Please, I'm trying to represent the formula for magnitude of vectors in three dimensions. That means whenever you see ijk and you are asked to find a vector, so you are asked to find the magnitude of vectors in three dimensions, this is the formula to use. So to apply Pythagoras theorem here, we have this to be a squared. Please take note. Is equal to s squared plus y squared. Please take note. So our intention here is to make A the subject. So making A the subject letter here, our A will be equal to square root of s squared plus y squared. Please take note. But this is not the representation of magnitude. This A here is not representing magnitude. It can only represent magnitude when we show the symbol for magnitude. So what is the symbol for magnitude? That is magnitude of A will be equal to plus square root of s squared plus y squared. Please take note of this. So this is the formula for magnitude for two dimension. We have x and y, we call it two dimensions. We have s, y, z, we call it three dimensions. So if I'm given three dimensions, that is s, y, z, or I, j, k, the magnitude here will be expressed as a magnitude. A magnitude will be equal to plus square root of s squared plus y squared plus z squared. Please take note of this, okay? So this is for three dimensions. This is for three dimensions. So let's apply this formula here to find the magnitude of that vector. If you apply this formula here, if you look into this vector here, it's two dimensions. Please take note. If you look into this vector here, it's two dimensions. So the magnitude I'm going to take here will be this particular formula here. That is, for force, it will be force magnitude will be equal to square root of s squared plus y squared. Please take note. So let's take the formula to find the magnitude of the resultant force. The word resultant means the total force. Okay, since there's no other force here, we take this force to be 6i plus 15j. That is the only force in that particular equation. Okay, so now let's calculate for the magnitude of this force here. That is, this will be equal to plus square root of s squared plus y squared. So F magnitude will be equal to square root of, okay, now let's take the s. Remember, I is the same thing as s, j is the same thing as y. So if you replace your values here, this will be 6 all squared plus the plus is the plus in this formula here. Replace your y, that is j, will be 15 all squared. Okay, now I will have this to be 6 all squared is 36. I will have this to be 36 plus 15 all squared is 225. 225. So punch your calculator. 36 plus 225. What is the answer? The answer will be 36 plus 225 will be 3261. Please confirm from your calculator, please. 36 plus 225, that is the magnitude of the force, will be equal to plus square root of 261. That is, the value will be 16.155 Newton. So if you approximate this to the nearest whole number, our force magnitude here will be equal to plus 16 Newtons. So this is my answer here. Okay, now let's solve the next question here. But before we solve the next question here, class, please just hit the subscribe button there to get more video on this particular topic here. Thank you.